Hi, everyone. It's daytime here. Good afternoon. I hope you are doing well and we are watching the videos and you are practicing. Okay, so I want to go into other studies I mentioned that we are going to use to guide us conduct fuzzy synthetic evaluation. So I want to start by saying that the materials that we are going to use in this video are purposely for educational assistance, and they are not meant for any profit or making any advantage or causing any harm to anyone. And the materials or anything that we are going to use here, it can be seen that they have been fairly cited and illustrated purposely to assist students. Okay, so in the previous video, when we started the fuzzy synthetic evaluation, I introduced you to the whole concepts, and then also we did some mathematical assessment by using Excel. I did everything in Excel. And today to do the same. But if you remember, the paper that we used, or I guided you with, was a paper written by Dr. Wuni, the last paper on this reference list. So today we are going to use this paper as a guide, extract some of the things from this paper, in addition to other things that I also take from the internet to assist you. The last video I will make will be concerning or will be related to a paper written by Akomea. So I believe that by the end of these three papers, after going through with you, I am hopeful that you can write a paper, a journal article using a fuzzy synthetic evaluation model. Okay, so let's go into the paper. So what I'm going to do with this one is that because I introduced you to that and we did a lot of mathematical work with respect to the other paper, I'll make references to some of the things that we did last week. But at the same time, I'll just take you through them step by step, the paper step by step, so that where there's a need for us to make some calculations, I'll open the Excel sheet so that we make the calculations. Where I think they are not important, I will just explain them based on what the paper has presented. So let's go into the paper by Osechi, Chan, and Akomea in 2017. And the title of that paper is A Fuzzy Synthetic Evaluation Analysis of Operational Management Critical Success Factors for Public-Private Partnership Infrastructure Projects. And this paper was published in Benchmarking, an international journal. So please understand that the paper is purposely for educational purposes. They are not meant for any other reason. So all copyrights are reserved, and the author has been duly acknowledged. This is not my own work. This is from the authors, and the copyright is with the journal and even the publishing site, which is Emerald Insights. Yeah. So if you want to get a full copy or use any full copy purposely for any other reason, you can contact them for the full copyright things. I mean, you sort it out to them and they will help you out. So let me go into the paper. So I will go straight to the methodology session because that's our main concern. And from methodology, I will take you to the analysis where we see the fuzzy synthetic evaluation. So research methodology. So if you look at this paper, which is on critical success factors of PPP projects, the study adopted a questionnaire survey. And in this case, they conducted an international survey. An international survey means that the survey was conducted in more than one country. Or you can also explain it this way. Respondents came from different parts of the world. Okay. So everything has been explained. And then the sampling technique was purposive sampling. Okay, so you can explain. Then survey monkey was used to distribute the survey. I normally use Quatrix, but we have survey monkey too. You can also use survey monkey. And then other studies too. Sometimes you also see that they use other techniques of distributing their survey. So any of them that you use is acceptable. Okay. Okay. So all these things, they explain them and all that. And then it comes to what I've been doing with you, and it has to do with the literature review. So if you look at this table, which is table 1, they have presented, the authors presented the critical success factors that they extracted from the literature, the existing literature. So they extracted, and then in addition to the extracted, which is in the first column, they also describe each of the success factors, and then they provided the source where they took them from, or where they got that success factor from. Okay, so you need to do this, and once you have this, I mentioned to you the other time that you have to do this, and once you get it, then you put it into the survey, which will form part of the design of the survey questionnaire, and then you distribute it. It was distributed, participants responded, and then it was realized that 43% of the respondents came from academia, and then 57% came from the industry. Okay. And then what was the response rate? Was the response rate discussed? Let me see. Into the time. Okay. So a total of 45 responses were received. However, 3 of the responses were found to be incomplete and therefore were discarded. Remaining 42 valid responses for the analysis. So 42 responses was received. Okay. That's okay. Then let's come to the statistical analysis. So this is where the main work is. So SPSS was used as we have been using, or as we used it in our previous analysis. Okay. What again can we see? Then the fuzzy synthetic was adopted to purposely establish the criticality and importance of each of the critical success factors grouping. Okay. Then the study went ahead to explain how the fuzzy synthetic evaluation was done in terms of the modeling. So this is how the modeling was done, as we saw it in the study conducted by Rooney and others. So this study cited Liu 2013, and then Qi, Zhu, Yong, Zhang, Chan, Wang, and Qi 2010. So the procedure for carrying out the fuzzy synthetic evaluation is as follows. Determine a set of criteria or factors. So this is where I mentioned that you need to establish your critical success factors, either before or after the factor analysis. Then establish a set of grade alternatives. The set of grade alternatives are the scale measurement adopted for the study. In this regard, the 7 points in this study, they use a 7 point, or the study utilized a 7-point Likert scale. Okay, Likert scale for the questionnaire and also for the alternative grade or the grading of the alternatives. But if you look at Woodney's paper, they set 5-point Likert scale. They use 5-point Likert scale. So this is how they explain their 7-point Likert scale. So for E1, is extremely low important. E2, very low important. 3 means low importance. 4 means moderate. 5 means important. 6 means very important, and 7 means extremely important. Okay, so depending on how you want to establish yours. If you remember last time, I mentioned that you can also make yours maybe 5 Likert scale. And with a 5 Likert scale, you can say 1 is strongly disagree. 2, disagree. 3, neutral. 4 means agree. And then 5 means strongly agree. If you remember, I explained this to you last time. So you can use 5, you can use 7, you can use 9. Depending on how you set up your survey questionnaire, or depending on the data set that you are working with. The third step in the modeling process is to establish the weightings for each of the factors. So each of the basic factors, that's the set of factors that you determine in the step 1. So you need to determine a weight for each of them. In addition, you need to also determine a weight for the group that they come in, where like very soon you see it from the factor analysis, the factor groupings. Okay, so we'll see that very soon. Then the fourth step is to compute for the fuzzy evaluation. So this is where the actual fuzzy is computed. Fuzzy evaluation is done. And fuzzy, as I explained to you the other time, is a matrix, comes in the form of a matrix. Yeah, comes in the form of a matrix. The matrix is expressed as the degree to which alternative, which is the grading, satisfies the criterion, which is the weighting and then the gradings meet. Okay, so once you are able to determine the fuzzy evaluation matrix, then the last step that you are supposed to work on is, the last but one, not the last one. The last but one is for you to determine the results for the evaluation by considering the weight factor and then the fuzzy evaluation matrix using this equation, where D is a final evaluation matrix and O is a fuzzy composition operator. It is more of like also a form of multiplying or more form of evaluation. Evaluation in this context, I mean computation, multiplication. Then the last step is to establish the final result by normalizing the final evaluation using equation of this, which will help us to determine the criticality of each group and then the overall data set, overall groups or the data sets. Okay, so let's go into it because this looks a little bit abstract. So in doing this analysis, the first thing that was done was that factor analysis was conducted based on the mean rankings of the 19. So when the data set was ranked, so there are 19 variables. I think it has been established that all of them, because here is a case where you are having a mean of 4 and above, and you are looking at a 7-point Likert scale. So if you have a 7-point Likert scale, then at least the minimum should be 3.5. If you are getting 4 and above, all of them having a mean of 4 and above, then that means all these data sets are okay. Okay, however, considering factor analysis technique for factor groupings, a recommended variable to sample size ratio of 1:5 is often a prerequisite. Okay. Nevertheless, the appropriateness of this analysis technique to sample data could also be determined through some preliminary statistical tests, including correlation and anti-image matrix, KMO, Bartlett test of sphericity, and reliability test. In other words, he's just trying to help us to know that before factor analysis can be properly conducted, you need to check the data set, whether it's appropriate, like the sample size. Is it appropriate? And then also you need to also conduct some basic statistics to determine the reliability, the adequacy, and then other things which are related to factor analysis. And all these things, we have done similar ones in the previous video. Hence, if the statistical test values are proved favorable, despite non-conformance with the recommended sample size ratio, factor analysis technique could proceed with full confidence and reliability. Okay, so it's all these things are just trying to help us to accept that this factor analysis that was conducted in this study is or was acceptable. Okay, in this regard, preliminary tests were conducted to ascertain the appropriateness of factor analysis technique in this study. Okay, so first, the internal consistency of the data was checked using a Cronbach alpha, which has values ranging between 0 and 1, as suggested by Nunnally, 1978. A Cronbach alpha value greater than 0.7 is acceptable. So this thing has also been explained. I've explained to you the Cronbach alpha which is acceptable and the ones which are not in the previous videos. A high value of 0.822 is achieved for the data set. So when this reliability test was conducted in this study, it was determined that 0.88 was the value that was achieved. And because of that, it makes it the data set reliable and with appropriate internal consistency to conduct this analysis. The relationship among the factors was also measured based on the partial correlation coefficient as correlation and anti-image correlation matrix. Correlation matrix indicates a strong correlation among the 19 factors, except for 3 factors, CSF, which rather have very low correlation coefficient with other factors, recording coefficient values less than recommended 0.3. So you need also to set the correlation threshold. So which correlation is low, which correlation is high. So normally correlation between factors, variables, ranges from -1 to +1. -1 means that -1 is perfectly or perfect, strong, weak. I would say, if I'm using the way I would say, perfectly weakest there's a word like that, or has the weakest relationship between them. Okay, and then oh, that's wrong. Let me put it in a better context. Negative one means that it has a strong negative relationship. It's not just because it's weak. Sorry, it's not weak, but rather negative relationship. And then positive one means it has a strong positive, which always is a perfect relationship between variables. When the values are drawing closer to 0 after 0.5, then they are showing weak relationships, whether negative or positive. Okay, so for example, if you have something like 0.2 or 0.1 or 0.004, you must know the kind of relationship that exists. Okay, so all these things we have done them, we have worked on all these things. I think I have to skip some of the things so that we can move on, because I've spent my time to explain these things to you. So I don't want us to lose sight of what we are doing. So yeah, so all these things were established, including the KMO and then Butler's test of sphericity and so forth and so forth. And they were all established to be okay, including the principal factor extraction method of using Varimax. All these things I've explained them in the previous video, so get them. Okay. So make sure you get all these things, which will help you to understand them from the previous video, in previous videos. Okay, so in this study, what was established was that after a factor analysis was conducted, 5 factors were extracted. 5 factors. 5 factor groupings were extracted, and they come with their names. Okay, and the table 2 give us, or table 5 rather, you can consider as table 5, that's fine. Okay, the table 5 give us a better picture of the results from the factor analysis. So as you can see, there are 5 groups, and under each group we have sub variables, or we have variables under each of them. So group 1 has some factors and all that, and they have, the group 1 has the total eigenvalue of 4.7, and then the percentage of variance explains 29.377, and then the cumulative, okay, will come in. Then also group 2 comes in, group 3, group 4. The total or the cumulative percentage of variance explained is 69.982, which is good, which is fine. Yeah, which is okay. Okay, so now we have our factor analysis. We know the groupings. We have also done the criticality analysis of the success factors, and we also know the mean. So we can go ahead and do the fuzzy synthetic evaluation, because normally these two things are the things that we need. These are the two things that we need to assist us to conduct a good fuzzy synthetic analysis. These two things are very important when it comes to the fuzzy synthetic analysis. Okay, so we have our criticality, Our factors is the mean. We also have our factor groupings from the factor analysis. There are 5. So now we come to the fuzzy synthetic evaluation. So first and foremost, the first condition that we established, or the first step that we established in the fuzzy synthetic modeling, which stated that we need to determine a basic set of criteria or factors, has already been determined from the criticality analysis. Or you can also take it from the factor analysis. Any of them is fine. We have also set our alternative grades, grades 1 to 7, with 1 being extremely low to 7 being extremely important. So we have this. Now the next thing to do is the third step, which is establish the weightings for each of the criteria, which we need to compute them here. So let's start. Okay, so to do that, what we have to do is, and that's exactly what we also did in the previous video. So you go back and watch the previous video with the Excel sheet. So first you pick the mean scores of the critical factors. Where did we pick them? Where did we pick them from? From table 4. So this mean, this column. Okay. So all the mean, each of the factors have their mean. Okay, good. So if you pick a factor like CSF5, if you take a factor like CSS5, the mean is 5.78 in this table. And when you come back to table 4, it's the same. Okay. So you bring all the mean that we establish in table 4 into table 6. That's exactly what has been done. Okay. So you do that, you do that, you do that. Oh, good. Then what's the next thing? So the next thing to do is, once you have been able to get all the means for all the variables within a group, all that you have to do is that add the mean. So 5.78 plus 6.04 plus 5.83 plus 5.61 plus 5.73. These variables, they come together to form 1. So when you add 1, 2, 3, 4, 5 items together, it will give you 28.99. So you can also do the computation yourself. Then the next step is to compute the weight for each CSF. So how do we get that? Okay. So you take 5.78 of CSF5, then you divide it by 28.99, which is the total of all. And that will give you 0.199. If you take the second one, 6.04 divided by 28.99 to give you this. 5.83 divided by to give you this. So you do the same till you get all. And you have to do the same thing for group 2, group 3, group 4, and group 5. Okay. So once you are done, the next thing to do is to, so this weighting is for each of the variables. Now we want it for the group, the entire group. So how do we get each of the group? So to get each of the group, what you have to do is that you have to add all the means, total means. In other words, you can even do it from here. You can instead of bringing it here, you can even just sum up all the means and put it under here. Put a total. It's the same. When you sum up all the individual means, it will give you 88.72. The same as you adding the group mean, because we derive the group mean from the individual mean, the total of the individual mean. When you add the individual mean together, you get the group mean. So when you add the group mean, the 5 groups, their means together to give you 88.72. It's the same as adding the individual mean of each of the variables together. It also gives you 88.72. So you can also try, you get the same. Okay, so once we get that, how do we get the weighting for each group? So to get a weighting for each of the group, you pick group 1. The total mean of group 1 is 28.99. Then you divide it by the total of all the means of each of the groups. So 28.99 divided by 88.72. That will give you 0.327. Then 23.21 divided by 88.72 to give you this. 9.52 divided by 88.72 give you this. 16.56 divided by 88.72 give you that. 10.44 divided by 88.72 to give you this. So by doing this, we have been able to establish the weighting for each of the variables and also the weighting for each of the 5 groups. Very simple. Very simple. They are not difficult. That's what the other time when I was doing this, I use Excel. But if you have an Excel, and you just use it's easy. Yeah, it's so easy. So easy. Excel makes it easy, very easy. Okay, so we come to the next step. And the next step after establishing the weighting from, I want to show you the step. So now we know the weighting. The next step is compute for the fuzzy evaluation matrix. And then from there, we go ahead to determine the relationships for the evaluation by considering the weightings factor and then the fuzzy evaluation matrix together. And then we establish the final matrix with this equation for each of the groups to determine the level of criticality. Okay, so now we have the weighting. So what next? The next thing to do is to determine what we call the membership functions. But before I go into the membership function, I want to say this with respect to determine the weighting, there are so many methods which are available to determine the weighting. Some use the mean score. Some use the results from analytical hierarchy process. Some use the point allocation system and so forth. So once again, if you check the last video I did, I introduced you to, I think, about 4 or 5 methods. But the ones which are very popular and common that many people use is a mean score. Yes, so in case you read another paper and you see that they are using or they have used a different method to determine the weightings of the variables and the groups, don't be surprised. Okay, so the next thing to do is that we need to determine what we call the membership functions. So to establish the membership functions, you need to know how respondents responded to each of the variables. And this is where I mentioned the last time that you need to do some work. Well, so far, I haven't seen any specific formula which you can use to just determine these variables. Yeah, I've tried to see whether there is even a formula or something which can easily help you to determine some of these things. I've checked, but I couldn't. What I realized from my analysis and all that was that what most studies do is to use how respondents responded to the survey, taking each variable into consideration, or considering each of the variables. So if you check my last video and the Excel sheet I gave out, if you remember very well, I showed you how I did mine. So I want to show you. So for example, with these factors, as you can see on the screen, they all have their responses, how they were responded with respect to the Likert scale. So if you can see, for example, this political extremism, we have 66 respondents. But on that political extremism, nobody responded to strongly disagree, but 3 responded disagree, 8 responded neutral, 36 responded that they agree, and the 19 said they strongly agree. Okay, so if you're going by this, what is going to happen is that you take a percentage of each of these things. So 0 divided by 66 times 100, 0. 3 divided by 66 by 100. 8 divided by 66, and so forth and so forth. So that's how I did it. So if you can see, yeah, it's divided by that. Okay, so that's how you determine the membership functions of the individual variables. I hope this makes sense to you. Okay, because so far I have not seen any specific formula or method, even though it's written this way, but I have not seen it. It's not done that way. So this is also written as, okay, so you write this as 0, others to 2 decimal places. 2 decimal places, that's why this is 0.00, this is 0.00. The reason why the fourth one is 0.10 is that it was run to 2 decimal places. So to run this to 2 decimal places, this 5 will turn into 1, add up to 9 to become 10. And then if it is 10, it can contain all the 10, you have to carry 1 forward. So this becomes 0.10. That's how come we had that. Then the next one, which is 0.24, how did we get that? It just also 2 decimal places. So 0.2, then the 8 will turn to 1 plus 3, 4. Then this, how did we get it? 0.445, 0.021. Yeah. So you have to adopting the same approach. Okay, let me go back. For the survey results indicated 95% the specific rated. Yeah. So how they rated, respondents rated the variables. Okay. So you see the percentages here. It's the same idea or the same mindset that made me do this. I went back to check my survey, and once again I said this is just, it was an example, just an example I'm giving. And when you go back and you check your survey, you'll be able to know how each of the respondents rated each of the variables. And then once you get to know how they rated them, you count the number of respondents that rated the variable that way, the number of respondents that rated the variable strongly disagree or agree or neutral or something. That's exactly what I have presented here. What I have done makes the work very easy. If you're able to do this, these are the responses from the survey. Makes it so easy. Total, my respondent 66. It's so easy. Yeah. So once again, go back and watch the other video, get more insight. Okay, so we have it for the individuals. The question then is, how do we get it for the group? Okay, how do we get it for the group? Okay, so before we answer that question, this has been presented in table 7. So let's go to table 7. Exactly, that's what has been presented here, as you can see. Okay, So the weightings and then the membership functions. Okay, I'm interested in the last but one column, the membership function of the individuals, and that is how we determined as level. Is that level 2? I don't think so. That should be level 3. Anyway, depending on how whoever is working, we'll read the other way around. Any of them is fine, but the Winnie's one is better. Okay, so this is okay. So the same thing has been presented as we saw it in the thing that I was reading in terms of a respondent's rating of the variable. The same thing should be done for each of the variables. Once it's done, the question is what next? The next thing that you have to do is that you have to multiply the weightings of the individual variables by the membership function. So how do you do that? So you take 0.199 times 0.00 plus 0.208 times 0.000 plus 0.201 times 0.000 plus 0.194 times 0.0000 plus 0.198 times 0.000. Once you are done, you add them together. You do the same thing by taking the weightings of each of the variables to the next column. You do the same, you do the same, you do the same, you do the same. And by doing that, you'll be getting this resource, which will come to form the membership functions for the groups or for the group. Okay. You do the same thing for all the other variables in the groups in that table. Yeah. Okay, so now there's something else that we have to do, which will lead us to table number 8. Table number 8. And that thing that we have to do has been specified in the other column before we go here. Okay, so we have done this, and that led us to get the table 7. I want us to get to table 8. With the membership function, yeah, all these things are done. Okay, calculating in this way, the membership functions of the remaining groups are computed using the same approach, and this is shown in column 5 in table 7. Yeah, we have done all that. Yeah, after determining the membership function of each of the groups, the criticality index for each of the factor grouping is calculated using this equation. So we want to determine the criticality index. So this is where we do the index. With the index, what you have to do is that you take each of the group membership function, and then you multiply it by what we set in step 2 as the grades alternative or alternative grades. Remember, alternative grade, we set it from 1 to 7. Okay, and then the membership function of this group, if you want to see the membership function of this group, go back to table 7, the last column. This. Yeah, this column. Okay, and then you do so, and at this point, it's more, once again, it's more in the form of a matrix. Okay, it's a form of a matrix. These are single column identity matrix, single column matrix. So how do you get this value of 5 points? 5 points. How do you get 5.79? How did you get it? So you take 1 times 0.01 plus 2 times 0.01 plus 3 times 0.00 plus 4 times 0.05 plus 6 times 0.46 times 7 plus into bracket 7 by 0.19. Let me do it again. 0.00 times 1, which is definitely going to give you 0, plus 0.00 times 2, which is also going to give you 0. Then 0.00 times 3, which is also going to give you 0. Then 0.05 by 4, plus 0.3 by 5, plus 0.46 by 6, 0.19 by 7. Then you sum everything together. You do the same thing for the second group, the third group, and then the last, but the last two groups, or the group 5. Okay, so by doing this, oh, okay. That means there are other things that Robert didn't do. Okay, so Robert didn't bother to establish a common. You know, in our previous paper, so as for this, Robert only determined the criticality index of the groups, and that he ended there. Robert didn't go ahead to determine even the overall criticality of all the factors. Remember, in our last video, we determined using the criticality index, we were able to determine the criticality level of each of the groups. Each of them, all the groups, each of the group were able to determine the criticality index of each of the group. Then from there, we determine the overall criticality of the data set. And then finally, if you remember, Dr. Wuni went ahead to develop a predictive model, which I even mentioned that it is something that is normally not needed. Yeah. So with respect to Robert's paper, he just ended at the criticality of the groups, and that's the end of it. Oh, okay. So that's fine. That's okay. That's okay. Yeah. So that's also acceptable. Yeah, because you don't. It's not required that you have to do everything. So that's fine. But honestly, I was expecting that you go ahead and then compute the final criticality. Yeah, so that's fine. So anyway, that's fine. Okay. So based on the criticality that we calculated, you can see that the group that came up with the highest critical value was the group 1, or group 2 rather, which had 5.82. Group 1 came second with 5.79. Group 4 came third with 5.47. Group 5 came fourth with 5.19. And group 3 came with 4.79 as the last group. So once you are done with this, then you interpret. I think Robert's paper is straightforward and it's easy to understand. Yeah, everything is straightforward. Yeah, it's so easy. It's understandable. Yeah. So I was expecting him to go ahead and also compute overall, but he didn't do that. That's fine. That's okay. Okay, so yeah, so as I mentioned, the rest you can read the interpretation. It went further to add more flesh to the paper by interpreting the results. So you can read it. But I think in a nutshell, I've been able to explain to you what this fuzzy synthetic modeling, what it is, and then how it was used in this study. So I'm happy for you to learn this. At the same time, I'll be grateful if you're able to get back to me with some questions, which will help me to understand or know that indeed you are learning and you know what you are doing. Thank you very much, and God bless you. Take care. Bye.